In 2018, several water companies raised concerns about contaminated water re-entering the main supply. RAS, Water Regulation Advisory Scheme, introduced measures to end this potentially dangerous situation, recommending the addition of an air gap to prevent the risk of backflow of blue water. Why is it called blue water, and what is the problem? In the UK, there have been cases where the water from the toilet cisterns had been drawn back into the supply pipework and even distributed to other outlets. This backflow was often identified because the water contained evidence of the dissolved cistern block, and these became known as blue water incidents because of the characteristic colour. An investigation was carried out to establish the root cause of contamination, and water companies identified the criteria that products need to satisfy to be compliant. RAS reviewed the following regulations. Regulation 4(1) of the Water Supply Water Fittings Regulation 1999. The Water Supply Water Fittings Scotland Bylaws 2014. The Water Supply Water Fittings Regulations Northern Ireland 2009. The solution has been identified as backflow prevention. The issue now is that several products on the market are effectively illegal and cannot now be specified or installed. Regulations now require the design of the overall WC systems to incorporate fail-safe elements that remove the risk of blue water backflow by inserting a physical air brake into the system design. These brakes are known as air gaps. A UK1 air gap covers the entire system and includes a requirement for a Type AG air gap on the filling valve. Type AG filling valves provide non-mechanical backflow prevention, creating a physical air brake between the lowest level of water discharge from a filling valve and the critical water level within a cistern. When combined with other required performance specifications, including the spillover level of the WC pan and size and shape of the overflow pipe, WC systems can meet RAS Type AUK1 air gap with interposed cistern approval. This is how an air gap has to work to be compliant. A visible, unobstructed and complete physical air brake exists between the lowest level of water discharge from an inlet valve and the critical water level in the cistern. It must not be less than 20 millimeters. The overflow must be circular and have a minimum internal diameter of 19 millimeters. The fluid in a cistern shall not come into contact with the inlet valve discharge outlet. The inlet valve must be of a BS 1212 Part 2, 3 or 4 design, which discharges above the critical water level. Viega has a number of products that are both RAS and KIWA compliant. For more details, visit www.viega.co.uk.